Welcome back, everybody. We're going to cover 1.4 equations of lines and modeling. So we're going to write equations of lines using either slope-intercept or point-slope form. So a reminder on point-slope form, y minus y sub 1 equals m times x minus x sub 1. X sub 1 and y sub 1 are an ordered pair, and m is your slope. So on example number 1, we want to write the equation of a line. We know a slope. We know a y-intercept, so it's going to be most beneficial to use slope-intercept form. Just substituting in the pieces that we know, that would be the equation of that line. On example number 2, we have a slope and we have a point. So I would go with point-slope form. Substituting in this ordered pair x sub 1, y sub 1, and just remember that your slope is m. Just putting in those pieces, we get y minus 6 equals m. M is negative 2/3 times x minus a negative 3. Now, we want to simplify this minus a negative, so we could rewrite this as y minus 6 equals negative 2/3 times x plus 3. And if the directions do not specify, you can be done. So this answer would work on a test if the directions just said write an equation of a line. Now, if it says it wants it in slope-intercept form, then you have a little bit more work to do. Just distribute the slope. So this would look like y minus 6 equals negative 2/3 x minus 2. Then add 6 so that you get it y equals, and we get negative 2/3 x plus 4. Oops, that got a little bit. So then that would also be a good solution. So it just depends on what the directions are asking and how you need to write the equation of the line. On a test, I would be super happy with this. On my math lab, it's going to typically make you write it in slope-intercept form, but always start with point-slope. I think it's a little bit simpler to do. All right, example number 3, we have 2 points. Well, no matter what, when we write the equation of a line, we need to have the slope. So the first thing you want to do is find the slope of that line. So that's going to be negative 4 minus 3 divided by 1 minus 2. Negative 7 divided by negative 1. My slope is positive 7. Now, this doesn't specify how we want to write the equation of the line. So let's go ahead and do point-slope form. I'm going to use this first point to start. So that's going to look like y minus 3 equals my slope of 7 times x minus 2. That is one correct, fully done answer. Let's say, though, that you wanted to use that point. Okay, then your answer would look like y plus 4, that would be minus a negative, changing that to a plus, equals 7 times x minus 1. That is a correct, fully acceptable answer. Now, if you needed to get that into slope-intercept, take either the red or the green, it doesn't matter, and distribute that 7. So I'm going to go ahead and take this first one. Y minus 3 equals 7x minus 14. That keeps dragging a little bit, sorry. Then add 3. So y equals 7x minus 11. And then that would be an acceptable answer. Now, you should never be doing all of this work. I'm just showing you how you could have different answers and still receive full credit. Just make sure you read the directions on how they want you to write it. Okay, so slopes of parallel lines. They have the identical same slopes, where perpendicular lines have opposite reciprocal slopes. So opposite reciprocal means one's positive, one's negative, and then that reciprocal means that the fractions are flipped. So to determine whether the lines are parallel or perpendicular or neither, the first thing you want to do is get them all into slope-intercept. So solve all of these equations in A, B, and C for y equals. So if you want to pause the video and just go ahead and write them all y equals, and then come back and see if you get the same ones I do, that would be great. Okay, so now that they're all in slope-intercept form, it's very quick and easy to figure out what the slope of the lines are. It's the number that's in front of x. So in this first example, the first one's a slope of 5, the next one's a slope of negative 1/5. Those are opposite reciprocals. One's positive, one's negative, and the fractions are flipped. So these two lines would be perpendicular to each other. Example B, slope is negative 2 and negative 2. Exact same slope, so these lines would be parallel to each other. Oops, I don't know, I put 2 R's. How about 1 R? And then on this last one, slope of 2, slope of negative 3, so these are neither parallel or perpendicular to each other. Okay, so now what it would like for you to do is to write the equations of the lines that would be parallel and perpendicular to that guy and going through the point 2, negative 3. So the very first thing that we need to do with this line is to figure out what is his slope. Because whenever we're dealing with parallel and perpendicular, it's all revolving around slope. So I'm going to start by getting that guy just y equals so I can identify what his slope is. So adding that x, so I'd have a positive x plus 20. Divide everything by 4. So y equals 1/4 x plus 5. So I know that the slope of this original line is 1/4. Well, in part A, I'm going to go ahead and write the line that's parallel. In part B, I'm going to write the line that's perpendicular. My original slope, we just said, was 1/4. So my parallel slope, and that is the notation for parallel in geometry, is going to also be 1/4. Where my slope that's perpendicular using that geometry notation is going to be negative 4, opposite reciprocal. Now I can go ahead and write the equation of the lines using this point and the two different slopes. So I'm going to go ahead and write them in point slope form. Y plus 3 equals 1/4 x minus 2. Y plus 3, negative 4, x minus 2. Now, if the directions don't specify what form, you are done. And if it wants slope-intercept, just distribute your slope and get y alone. All right, so that's all we're going to cover on our video for 1-4. We'll finish out the rest in class. Thank you.